Hi, this is Lakshmi Kantiwari. In this lesson, I am going to teach you about recursive feature elimination by using a tree-based and gradient-based estimator. So first, I'll tell you what is the RFE, and then we will start working with the the breast cancer dataset, where we select the where we identify whether the cancer is the malignant or just benign, and then I'll train and test this data set, and then this tutorial will be divided into the three sections actually. The first section is feature selection by a feature importance of random forest classifier, and then the another section is recursive feature elimination. That's when in the first sections we will be selecting the features based on the select from model of a scalar library, and then it find out all the features which have a importance more than the mean of the all features importance. And then in this step, in the recursive feature eliminations, we try to remove the one features by another, the least performing features. First least performing features get removed, then again it train the model, then again least performing features get removed. So with the RFE we get the better accuracy than on the original data set. On original data set we had got 96% of accuracy, but after the RFE we got the 97% of the accuracy. Then in the final section of this lesson we will learn about the gradient boosting algorithms, how we can select the features by using a gradient boost algorithm. And with that we select the total number of features, and then we get a maximum accuracy which will be the 99.12% if we select the 6 features. And then with this for loop I'll show you that how you can select the maximum how you can select the maximum performing the feature set. And then I'll tell you that those feature set which has performed better. And then finally I'll show you that even if we go ahead with the random forest classifier in the same way, in the random forest classifier we will never get a 99% of the accuracy. The maximum accuracy will be the 98.24% with the combination of the 17 features. So now you can see that with the RFE and the gradient boosting classifier, with only the set of the 6 features we achieve 99% of accuracy instead of just 96% of accuracy. So this is a kind of the win-win situation in which we have increased the accuracy by almost 3%, and we have reduced the feature space from 30 to 6, which is almost 1 by 5 times. That's just 20% of the total feature space. So in this way what happens, the accuracy get increased, training time get reduced, the model complexity get reduced, the chances of overfitting get reduced, and the model interpretability get reduced, the total space taken by the model get reduced. So there are so many advantages of a feature selection. Perfect. So without wasting a time, let's go ahead and start a lesson on a recursive feature elimination by using a tree-based and gradient-based estimators. Recursive feature elimination, as its name suggests, that it recursively removes the features and build a model using the remaining attributes, and then again calculate the model accuracy. So moreover, how it do? It train the model first on all the data set, all the features, and then it try to remove the least performing feature, and then again it train the model and find out the feature importance amongst the remaining the feature, and then again it try to train the model. Since it is kind of the recursive training of the model and recursive feature elimination, so it try to eliminate a feature recursively one by one. Scikit-learn does most of the heavy lifting, and the RFE module is available under the sklearn.feature selection, and we can pass any classifier under the RFE module, and then it will execute based on that estimator. Okay, and using the familiar scikit-learn syntax .fit method, we can train the models, and then finally we can select the feature. So in this lesson, let's first import the necessary packages: numpy as np, pandas as pd, seaborn as sns, matplotlib as a plt. Okay, and then after that we need to import the train test split, random forest classifier, select from model, and accuracy score from sklearn as well. So let's run this module, this Jupyter cell. And now in this lesson we are going to work on breast cancer dataset, where we need to find out whether the tumor is malignant or just benign. And let's first import the dataset in the Jupyter notebook that we can get from sklearn.datasets. sklearn.datasets, and then import load breast cancer. Okay, perfect. So this is the classification problem, where we are going to read the data inside the data variable load breast cancer. And as I have been doing, and I have been showing you how you can know the more information about the data, you need to just type there the keys. It will show you the available keys which we can apply on this data. So these are the keys. So let's go ahead and first get the description of this data file, and that we can get from the data.description. So right here the print, then data.dscr, and here we have a breast cancer data set. Total number of attributes are 569, and total number of attributes present here 30 numeric attributes. That's mean our input space have a 30 dimension features, and these are the features name here. So these are the total 30 features. Although if you see here their minimum and maximum, that's mean the scaling of these features are not on the same scale. But here, since we are gonna work with the tree based classifier, so in tree based classifier, these classifiers are very immune to variance of a data. That's mean it doesn't matter if the data set are not on the same scale. Okay, perfect. Now let's go ahead and load the dataset into x and y and the y vectors. So x in x vector, so we are gonna create pandas data frame there, x dot data frame, and their data we need data, and then column for this is data dot features name. Let's go ahead and see the first few lines of variable x, and these are the first 5 lines of variable x, which have 30 columns. That's mean input space is having the dimension of a 30. Okay, after that let's go ahead and read the target variables into y, and that we can get with the data dot target. Now we have x and the y. Let's go ahead, do a train and the test split, x train and then x underscore test, then y underscore train, and then y underscore test is equal to train test split, and inside that we need x, y, and test size is equal to 0.2, and then we need here random state. We need to write the random state is equal to 0. And now let's go ahead and get the shape of x train as well as the shape of x test. So with this we can understand what is the shape of our data, that the x train have 455 rows and 30 columns, and x test have 114 rows and 30 columns. Now let's go ahead. So we'll be actually working in 3 sections. In the first sections we will be doing a feature selection using select from model in sklearn library. In the second sections, we will apply a recursive feature elimination by using a random forest classifier. And then in the third lecture, we will, in the third section of this lecture, we will apply a gradient boosting algorithm to identify the feature set. So now let's go ahead. First, create the selector for random forest classifier. So that's mean we are going to do feature selection. Feature selection by feature importance of random forest classifier. Okay, then we have here the selector is equal to select from model, and then we have here the random forest classifier, where we are going to pass number of estimator. As usual, we pass 100, and then the random state I'm gonna set 0, so that you can also get the same result as I am getting if you set a random state a 0 and other parameters as I'm printing as writing here. Then we have a selector dot fit. So let's fit this model. That's mean let's find out the selected features. So we have x train, and then we have y underscore train. Based on this, now let's go ahead and get the total set of the features. Now with this we get these set of the features, and now let's go ahead and see what is the length of this feature. So this is the 30 actually, okay, sorry, but we need only the true. That I'll show you how we can actually estimate total features. But the one thing is clear here, with the selectors we can get the values where it is the true. That's mean those columns are selected, and that we can get with this x underscore train dot column. So with this we can understand, okay, that's mean the first the first feature is selected, but second is not selected. Then other two features are selected, and the similarly, I mean wherever it is the true, that's mean those features are selected, otherwise features are not selected. Now the question comes here, how this select from model select these features. It actually calculates the importance of all the features, and then it find out the mean of the importance of all features, and then it selects all the features which have importance greater than mean. And to understand this in the detail, let's go ahead first see which features are selected, then I'll show you how with the mean it is being selected. Then let's go ahead, we can write here the features is equal to x underscore train, then dot columns, and then we have cell dot get support. Okay, now let's go ahead and type these features. So these are the features which are actually selected, and we can get the length of those features which are selected. These features are 10. That's mean there are total 10 features which are selected. Now let's go ahead and find out the mean of those features, and mean of those features are, we can get with the selector dot the estimator, and then the feature importance. So with this we have the mean of the feature importance is 0.033, and now if we print the feature actually importance, then we can find out the total how many features are greater than 0.033. So if you see here, the features which have a value greater than this, those are selected. Like a first feature have a value greater than this will be the selected, but the second feature don't have that value, but this one and these features have a greater value. And one more thing, the greater the value, that's mean greater the importance. So the more importance, that's mean those features are very important, are more important, and the more related, I mean it has more importance to predict the output. So if you see here, I think the maximum important feature is this one. So this is the features which actually can predict very strongly the output. but you see this feature is very small, so this feature actually doesn't introduce much information while predicting the output. Okay, so these are the features which are very small features. Okay, perfect. Now let's go ahead and select the features. That's mean it has a total 10 features, so the new data dimension should be the 10. So let's go ahead and get the first training data set, that is the RFC, random forest classifier. There we have cell.transform. Okay, and there we have x underscore the train, and the similarly we have here. Now similarly we can select for testing dataset as well. So here we have x test underscore RFC is equal to select dot transform, and there we have x underscore test. Okay, so here we have a two dataset, training dataset and testing dataset. And since we have got our training and the testing dataset, let's go ahead and write our random forest algorithm as usual with run random forest. It takes 4 input, x train, x test, then y train, and then finally y test. And then we need to get the objects of the random forest with the CLF, and it takes the number of estimator which I'm gonna pass, that's the 100, and the random state I'm gonna pass here 0, and n jobs is equal to -1. That's when utilize all available core in my computer. CLF.fit. So let's train the model here, x train. Okay, so here you see the x train, that doesn't mean that the global value of the x train, but it is taking this local value. So it has a x train, and then finally we have y train. Okay, then after that we have y underscore pred is equal to CLF.predict, and then we have x underscore test, and then we have here the accuracy score y underscore test, y underscore pred. Okay, perfect. So here we have our random forest classifier, and then we are going to call this method, and there we are going to pass the data set which we have got after the feature selection. So those are the x, actually this should be the x train RFC, then we have x test RFC, then we have here y train, and similarly we have here y test. So with this we get the it says that the n estimator is not defined actually. Okay, so with this it says that the total accuracy which we are getting is 94.73% on the feature set which we have selected by using a simple select from model, and with the feature importance of a random forest classifier. And now let's go ahead and see what is the accuracy on the original data set. That means on the x train and x test, so that accuracy is 96.49%. so here you see we are getting at almost the 2% of the less accurate, the 2% of the less accuracy. But if you see the feature set has been decreased from 30 to 10 features only. Although there could be the other methods from by using which we can improve the accuracy during the feature selection. So those features we are going to here explore, and those features which we are going to do, we are going to utilize by using a recursive feature elimination. Okay, so let's go ahead and calculate that with recursive feature elimination. That's the RFE, and let's implement this RFE. And first we need to import the RFE. I think we have already imported, so we don't need to import it. So let's go ahead, work with the selector. There we have cell RFE, and then here we pass random forest classifier as usual. So there n estimators is equal to 100, and the random state we are going to pass here the 0 and n job is -1. And then here we have n features, sorry, yes, so we need to also pass the total number of features which we are going to select. That I'm gonna pass here 15. Now let's go ahead and fit this model. So once we fit this model with x underscore train and y underscore train, then it says that RFE is not defined. That's mean we also need to import the RFE from sklearn dot feature selection. So here we have recursive feature elimination. So it starts a feature with 30 set of the 30 features, and then again it removes the least performing features and it keeps removing a least performing feature. So that is how this RFE recursive feature elimination works. So let's go ahead and see which are the features which has been get selected by using this algorithm RFE. So these are the true values, that's mean these are the feature sets which has been selected for the training. So let's go ahead and get those features name actually that we can get with the x train, then dot columns, and inside that we can pass this selector get support. So these are the actually these are the features which has been selected for the training. So let's go ahead and see the length of the features, and there are total 15 features. Now let's go ahead and select only these features into a new data set, and that data set I'm gonna create with x underscore train underscore RFE. Earlier it was RFC, but now this is RFE. Then select dot transform, and there we have x underscore train. Then we have x underscore test underscore RFE is equal to selector dot the transform. There we have x underscore test. So here we have the two arrays, x train and x test here. Now let's go ahead, train and test it. That we can do by selecting these two cell and press C in your keyboard. It will copy these two cell, and I'm gonna just paste those cell by pressing a V in my keyboard. So this cell has been pasted here. Instead of RFC we are going to pass here RFE. Okay, now you see the accuracy has been increased from 94% to 97%, and the accuracy on the original data set is 96%, 96.49%. So now we can see here it is almost 1% of the accuracy increase by selecting the feature. One more thing you might notice here that the total selected feature is 15 here as well, and in earlier section the total selected feature was 15 as well. I think it was 10, sorry, it was not 15. So with the 10 selected features, the maximum accuracy we have achieved 94.73%, and with all the 30 features the accuracy is 96.49%. But with the recursive feature elimination, a set of the 15 optimal feature is giving the accuracy of 97.36%. Okay, perfect. Now let's go ahead in the last section of this lesson, which is a feature selection by gradient boost algorithm. Okay, so that we can do the feature selection by gradient boost tree importance. So let's go ahead, first import gradient boosting classifier. Okay, so there we have the import gradient boosting classifier, and then we have a selector here. Let's go ahead, I think we can just copy these from here itself. So let's go ahead, copy these cell from there to here, and that we can paste it with V, and Now here we have, we can remove this as well. With this here we have RFE, but here we need to pass the gradient boosting algorithm. So gradient boosting classifier, number of estimator is 100, but in jobs we don't need here, so just remove that. The number of features to select here, I'm gonna select the 12 features. Okay, so let's go ahead and select the 12 feature, and let's go ahead and train this. So it might take a little time while training the gradient boosting classifier. Once it is get trained, then it shows you the selected features, and the length of the selected feature is now 12, since we have specified that select a number of features, that's the 12. Now let's go ahead and get new data set into the RFE, keep running it, and once we run this algorithm, it says that instead of the 15 features, we have now selected the 12 feature. With this gradient boosting classifier, now we are again getting a 97.36% accuracy, which is quite good accuracy, and in fact that is a better accuracy than the accuracy gotten by the original data set. Now let's go ahead and see the one thing you might have noticed that here, so we are selecting the number of features to select the manually. Okay, that means how would you identify that how many set of the feature is performing best? So we are going to write a for loop here, and with that for loop we are going to loop the number of selected features from 1 to 30, and then manually we can see that how the recursive feature elimination is working. That means if we have 30 set of the features, then what is the accuracy of for 29, what is the for 28, 26, 25. So it will keep decreasing or keep increasing. So in a similar way, now we are going to test what would be the accuracy for all possible the number of selected features from 1 to 30. So the for index in range of 1 to 31, that's mean range from 1 to 30, we are gonna write the same thing. We can come here actually, and we can copy this. So let's go ahead and copy this. Then after that we need to do the feature selections here, the transformation. Actually we are not going to print these things because the first time it will be selected here. Let's put here the index. So in the first iteration, the total number of features which will be the selected in final selection will be the 1. In the second round iteration, the 2 features. In third round there would be the 3 features. Okay, after that let's go ahead and print the iteration number there. So there I can say selected features, and the selected feature means the iteration, and that's mean the index value, and then we are gonna run here the random forest based on the RFE, that's mean the selected feature set after getting selected from these 2 lines. Okay, so here we have xtest, sorry, this should be the actually the train xtrain RFE, and then here we have xtest RFE, and then here we have ytrain, and then here we have ytest. Okay, so here with this we are going to print a new line. So let's go ahead and run this and see what will be the accuracy for each selected feature. So for a first feature, if we select only one feature, the maximum accuracy is 87. But if we select the 2 feature, the accuracy is 90. For a 3 feature, accuracy has increased to 96 feature. Now here you can see that in original data set there is a 30 feature, and those features were producing this accuracy. But after the feature selection techniques, now we are getting just a 3 feature. After selecting the 3 features, we are getting a 96.49% accuracy. That's mean the same accuracy. That's mean if we are getting a same accuracy or more accuracy with a less number of features, then why do we need to include all the features? That's mean actually we don't need to include all the features. We only need to include those features which perform better accuracy or give a better accuracy. Wow, you see here, if we select the 6 feature, Now if we select the 6 feature, with these 6 features you can see that the maximum accuracy is a 99.12%. That is the fantastic. So here you see all the possible the accuracy with the all possible number of selected features. Okay, so you would not, I don't think you would see a 99% accuracy for other number of features. So the feature selection techniques works really great. So it says that the total number of selected feature, if we select the 6, then the accuracy will be 99.12%. Let's go ahead and see what are those features. If we select the 6 features. So let's go ahead and copy this. You need to press Ctrl and C in your keyboard and paste it here. Once you paste it, you will see that there is a space. Then to remove those space, you can highlight this and then press Shift and Tab. That means it will go into the backward direction. And since we are going to select the 6 feature subset, and with these 6 feature subsets, let's go ahead and train this model. Then we should get 99.12% accuracy. Perfect here. Okay, the index is of course the 6. Now let's go ahead and see what are those features which has been selected in this 6 feature. And to know, to get those features, we can get from here the features is equal to x_train dot columns, then cell dot get support. Alright, so with this we have here total number of features, right? So the total number of features are the 6, and these are the maximally performing features which has been selected for our final predictions, where we have got a 99.12% accuracy. Perfect. So here one thing, we have chosen the gradient boosting classifier. Now let's go ahead and choose here the random classifier, the random forest, as we had chosen here. Okay, as we had chosen here the random forest classifier, and then see what will be the accuracy if we changes the total number of selected features. I think that thing we can put here at the last. So let's go ahead and see it here with the random forest classifier and the n jobs. I'm gonna select here the -1. That means select all available core in my computer to train this model. So let's go ahead and run this model. Now it will select the features based on the random forest classifier. Earlier it had selected the features based on the gradient boosting classifier, but it did classifications based on the random forest classifier. So the feature selections was done based on the different estimator, but the classification was done on a random forest classifier. So with the random forest classifier, now it is getting selected with the first feature has performed 89%, second 92. In 4 features we have gotten 96%. Now you see there is a difference. In the third feature we have got just 94% accuracy, but with the gradient boosting in the third feature we had gotten 96% of the accuracy, which was almost equivalent to the original feature set. And now you see the feature is increasing. Now even at the 6th feature set, the accuracy is not increased. It is somehow varying from 96.49 to somewhere 95. So we can wait for a little time to test it, how it is performing over the other feature set. And we can wait for a few seconds. Now let's go ahead and see what is the maximum accuracy which we have achieved. So it seems we have got around 98% if we select the 17 feature set. Okay, and I don't think we have got above than 98.24% of the accuracy. Yes, so the 98% of the accuracy, and that we had achieved after selecting the set of the 17 features. Okay, so this is the how it is working. If we go ahead with the random forest classifier feature selection, then we achieve 98% of accuracy. But if we go with the gradient boosting classifier, then we achieve a 99% of the accuracy. And this is the way how we select our number of features to improve accuracy and reduce the training time. Although with the RFE you can select the other estimator as well, and this would be really fantastic to see how accuracy will be increased and total training time will be reduced. So thank you so much for watching this video. I think after one or the two video, this will be the end of the feature selection video series, and then after that I'll be making on the deep learning perhaps soon. Okay, keep watching. Please don't forget to like this video and subscribe this channel so that you can get updates into your inbox. Bye bye, have a nice day.